So we're starting 11.2, guys. Systems of linear equations, and we are studying matrices. So the definition of a matrix is defined as a rectangular array of numbers. Each entry we call it A subscript I subscript J, where I is the row, I is the row, and J is the column. So an example would be, we're going to have, let's do row 1, row 2, skip a few, row I, and the last row, since we don't know where we're ending, let's call it N. So the I represents the row, and the J is going to be the column. So column 1, column 2, skip a few, let's say column J, and then column N, just like that, okay? All right, so if it's the first entry, that's row 1, column 1. So we write A11. So row 1, column 1. Now A, row 2, because that's subscript, I'm sorry, row 1, column 2, so A12. Skip a few, A, row 1, J, and A, row 1, N. So the number, the subscript 1, and you have another number, so that's going to be the column. Now row 2, column 1, that's A21, A22, so represents row 2, column 2, A2J, A2N, okay? And we're going to skip a few down here. So now this is AI1, AI2, AIJ, and AIN. Then our very last row, we call it row N, so that means this is AN1, AN2, ANJ, and this is ANN. So again, the subscript represents row and column. Augmented matrix. So an augmented matrix is a matrix used to represent a system of linear equations. Variables must be on the left side. And constants are on the right. Okay, so let's go and try to do example number 1. Example 1 says, write the augmented matrix of the given system of equations. So as you can see, you have 3 variables, 3 equations. It says here, variables on the left, constants on the right. So we have 6x, so we don't write the x with it, we just write 6. We have 2y, we write the 2, and negative 1z, so that's just negative 1. Now the constant, the first constant of the first equation is 0. Now the second equation, we have 1x, 1y, no z, so that fills in with 0. Yes, you have to have a 0 there. And the constant would be a 4. And the third one, we have 2x, 0y, and 5z, and that constant for the third equation is 2. So that's an augmented matrix. Coefficient matrix is an augmented matrix with only the left side. Okay, so we are going to use example 1 to do a coefficient matrix here. So the only difference is that now you only have the left side, which is all the variables, okay? 6, 2, -1, 1, 1, 0, 2, 0, 5. And that's the difference between an augmented and a coefficient. Reduced row echelon form. There are 3 conditions, okay, students? Okay, condition number 1. Entry in row 1, column 1 is a 1, and all the zeros below it. So entry in row 1, column 1, that means is A11, is a 1, and zeros below it. Condition number 2. The first non-zero entry in each row after the first row is a 1 and only zeros below it. The first non-zero entry in each row after the first row is a 1 and only zeros below it. Last condition. Any row that contains all zeros. Any row that contain all zeros to the left of the vertical bar must appear at the bottom. Must appear at the bottom. All right, so let's draw up an example of your reduced row echelon form. So I'm going to make a matrix like that. Now it says here, condition number 1, entry in row 1, column 1, it's a 1. Okay, so that means row 1, column 1, it's 1, and it says zeros below it, just like that. Then, so that means is, if I were to do 3 columns, right, so these 2 spots right here, those 2 spots can be anything it wants to be. So you don't have to have a 0, you don't have to have a 1, you can have any number you want. You can have a 0, you can have a 1, it's just that you can have anything else you want, okay? So let's call it A and B. Now, condition number 2 says the first non-zero entry in each row after the first row, it's a 1. So again, here's a 1. And then that means that spot could be anything you want to be. It can be 0, it can be 1, it can be non-zero, non-1. Then that means we have 0 here, and this is now a 1. So look at the diagonal. The diagonal, it's all 1s, okay? Now we have the constants on the right side. It can be anything it wants to be, so let's just use the variable D, E, and F, where A, B, C, D, E, and F, they're all in a set of real numbers. I mean, it can be anything they want to be, okay? All right, inconsistent is when the system of the equations don't meet. That means you have no answers, okay? Is when the system of equations don't meet, aka no solution. Oops. Consistent is when the system of equations have at least one solution. Okay, so normally, guys, you have one solution or no solution or infinitely many solutions. Okay, so the two choices would be one solution for consistent, and the second one would be infinitely many. Now you're going to have infinitely many solutions when you have all of your equations or all of your lines line up one on top of another. You have one solution is when they intersect at exactly one place. All right, guys, example 2. Let's go. Write the system of equations corresponding to each augmented matrix. Okay. Then perform the indicated row operation or operations on the given augmented matrix. So there are two things that they want us to do here. The first is to write a system of equations for the augmented matrix that they gave us. So for 2A, looks like they gave us a 2 by 2. What I mean when I say a 2 by 2, I mean 2 rows by 2 columns, okay? So we got 2 minus 4, so that's 2x minus 4y, and your constant is a -4. Then the second row, we got 3x minus 6y, and the constant is -5. So that's the system of equations that we need. Now, it says then perform the indicated row operation. Here's the row operation. This is red. R sub 2 equals -3 times R sub 1 plus R sub 2. So this right here, students, means only row 2 is changing, okay? So when you see the big capital R with subscript, only, well, I can't spell only, why can't I spell only? Only row 2 is changing, okay? All right, so it says here, take row 2, we're about to change it by, this right here means we're about to take -3 times the value in row 1 and add the value of row 2. So what I mean by that is, let's make a big matrix here to show our work, okay? Okay, only row 2 is changing, so what we're going to do is write row 1 values back. That is not changing. Now row 2 is changing by taking -3 times the value from row 1. Well, row 1 currently has a value of 2. Then we're going to add the value from row 3. Well, row 3 is 3 right there. Not row 3, I'm sorry, row 2 is 3. So now we add, oh, why can't I write? There you go, add 3. In a little bit, we're going to go down and simplify that a bit more. And we do that for all the values in row number 2. Okay, so take negative 3 times the value from row 1, which in this particular case is negative 4, and add row 2 value, which is negative 6. Do the same thing. Negative 3 times row 1, which is negative 4, and add negative 5, just like that. So now I'm going to make one more matrix and then simplify this out, okay? All right, so this is 2, negative 4, negative 4. That never changed. Now, let's do the basic math for row 2. Negative 3 times 2 is negative 6. Negative 6 plus 3 is going to be negative 3. Negative 3 times negative 4 plus negative 6, that's going to be positive 6. Negative 3 times negative 4 plus negative 5, so that's going to give us 7. So guys, box this up. Now make sure you guys know how to do your row operations really well, because you need to know how to do each and every row so you can use it to solve later. Okay. Now, example 2b, we have a 3 by 3. Normally, when I say 3 by 3, I don't really count this last constant row. Okay, so that means 3 variables, 3 equations. So that's what we have to do first, write the system of equations. So that would be 2x plus negative 3y plus 4z, and your constant is negative 6. This is now negative 5x plus negative 6y plus negative 4z equals negative 6. And yes, you can just go straight to negative 5x minus 6y minus 4z. You don't need to do a plus and then a negative, okay? Then your third equation is negative 4x minus 3y plus 5z equals 8. Box that up because that is one set of the instruction, okay? Now for example 2b, it's asking us to change row number 2, and it's asking us to change row number 3. So be very cautious, okay? And again, I'm going to make a big matrix here so I can show my work. All right. Row 1, we're not doing anything on row 1. So we are going to copy that over. That's 2, negative 3, 4, and negative 6. All right, let's change row 2. Row 2 says take 2 times the value from row 1, which is also 2, and add the value from row 2. So that's now add negative 5. Whoops, can you see that negative or no? Add negative 5, okay? Then same thing with the column number 2. Take 2 times the value from row 1, which is negative 3, and add value from row 2, which is negative 6. Third entry here on row 2, take 2 times R1, which is from row 1, which is 4, add R2, which is negative 4. Same thing for the constant, 2 times the value from row 1 plus, this is negative 6. Okay, and our final matrix, we can do the basic math for that. So next I'm going to erase all of this so I can do that again for you on row 3. So row 3 is slightly different. Row 3, we're changing row 3 by taking 2 times value of row 1, which is also 2, okay, which is here. And then it says here, add value from row 3. So row 3 happens to be negative 4. Same thing on the middle entry here, 2 times negative 3, and the value from row 3 is now negative 3. Same thing, 2 times row 1, which is going to be 4, add value from row 3, which is positive 5, and one more, 2 times value from row 1, which is negative 6, add 8, since that is the value from row 3. Okay, so each column, you maintain its position, all right? Now I'm going to make one more matrix right in the bottom so we can do some basic math and then box that up. So 3, okay. Okay, now let's write 2, -3, 4, and -6 back down because we did not change row 1 at all. Sometimes we do, but in this case we did not. Then let's do some basic math for. I'm going to use red, okay? 2 times 2 plus a -5, that's -1. 2 times -3 plus -6, that's -12. And then 2 times 4 plus -4, that's +4. And my last red answer over here, 2 times -6 plus -6, that's now -18. Let's go to the green. 2 times 2 plus -4, that's 0. And this one right here, 2 times -3 plus -3, that's -9. Then 2 times 4 plus 5, that's 13. And my last green answer, 2 times -6 plus 8, that's -4. And then let's box it up. So the 2 rows that we change were row 2 and row number 3. For example 3 in chapter or section 11.2. The reduced row echelon form of a system of linear equations is given to us. Write the system of equations corresponding to the given matrix. Use xy or xyz as variables. Determine whether the system is inconsistent or consistent. If it is consistent, give the solutions. Okay, so this is given to you as an augmented, right, matrix. And in an augmented matrix, this is more than that. This one's giving to you as reduced row echelon form. That means the diagonals all 1, supposedly. Well, check out this last one, right? That last row, it's all zeros. And remember, in the reduced form, there you go. In the reduced row echelon form, we talked about this as one of the conditions, right? Any row that contains all zeros on the left-hand side of the vertical bar must appear at the bottom. Well, this one, it's all zeros, so now it's at the bottom. This means right here, that means this z is any real number that you want it to be, okay? So again, if there's a zero, if you have the entire row of zeros, you're gonna move it to the bottom, especially zeros on the left-hand side, okay? That means z is anything it wants to be, okay? Again, if you have all zeros, that means z is anything it wants to be. Well, because z is anything it wants to be, I can write this system of equations this way. 1x plus 0y, which is technically, I don't even have to write, plus 4z equals 4. 0x, okay, plus 1y plus 3z equals 2. But I'm going to make this, I don't want to write the 0 in there, so this is really technically x plus 4z equals 4. This is still the same, but I'm going to not write the 1. Okay, so this is going to be y plus 3z equals 2. Because the last row of this matrix is all zeros, I don't have to worry about it. Well, you have two equations, two systems, right? I want to solve for it. So to solve for it, I'm going to solve for, let's say, x. Okay? Let's solve for x. X equals, okay, here we go. I'm going to move the 4z, so 4 minus 4z. I'm also going to solve for y. Y equals 2 minus 3z. Okay. Now, because the last row is all 0, that means we can choose our z. The answer, that z, it's going to belong in any real numbers, a set of all real numbers, or in this case, z is any real number that you want to pick. Whatever you pick, x depends on what you pick for z. So since I can't pick a value, and no, you can't pick a value either, so we're going to say x is 4 minus 4z, and y is 2 minus 3z, and z is any real number. Okay, so this one right here, we're going to have a bunch of different answers depending on what z is. So because we do have an answer, this is consistent. Okay, so consistent means you have at least one answer. So that's example number 3. So this is example 4 from 11-2. Solve each system of equations using matrices. So that means you have to use matrices, okay? No ifs, ands, or buts about this. If the system has no solution, say it is inconsistent. So we have A and B. Obviously, A looks a lot easier and B looks a lot scarier. So just to kind of organize, so that way I'm not like crazy messy, I'm going to divide this up. As you can see, B will require lots and lots of space. So let's do A first. To solve using matrices, you want to, step number 1, write it as an augmented matrix. So we have 3 equals to 3, 4, 2 equals to 8 or 3. Step number 2, you want to reduce this into row echelon form. So row echelon form. That means the diagonal's got to be 1s, and then below it, it has to be 0. So the first thing, for this particular example, I'm going to change one row at a time. So this one, I will change row 1. To get 3 to become a 1, I'm going to multiply the entire row by 1/3. If you change one entry in the row, you got to change all of the entries. So this is now 1, 1, and it happens to be 1. Row 2, I did not change it this time, so I would just copy it straight up. Now step number 3, remember, keep on going until you get all of the diagonals are 1, and below that will be 0. Step 3, we are now going to try to get the 4 into a 0. Now to do that, I'm going to change row number 2. To get that into be a 0, you want to multiply its -4, whatever the number is, you want to multiply its opposite, to the row above it that contains a 1. So in this case, there's only 2 rows. So the row above it is a row 1. And then you want to add itself. So that is now row 2. So this is going to give us, again, this particular operation, I'm only changing row 2. So I don't need to do anything to row number 1. So here we go. -4 times 1 is going to be -4. -4 plus row 2, which is 4, is 0. So that's why it works. -4 times 1 is -4 plus 2 is going to be -2. -4 times 1 is -4 plus 8 over 3 will give us a -4 over 3. Almost there. We now just have to change this into a 1. So that's changing row 2 again. And to get that into a 1, I'm going to multiply its reciprocal. Well, what do you change to 1 entry? You have, row 2. You have to change it to all of your entries. So row 1 again remains unchanged. So 1, 1 equals to 1. 0 times a -½ is going to be 0. 2, -2 times a -½ is a 1. -4/3 times a -½ is a positive, and that will give us a positive 2 over 3. As you know, this is x, this is y, and then equals to a constant. So right away, look, you have a y equals to 2/3. Bam, you're done with y. This can be rewritten as y plus x plus y equals 1. If you know y is 2/3, we can definitely solve. This will become x plus 2/3 equals 1. I mean x equals to 1/3. You have y right away. We solve for x, so we write it as an ordered pair. 1/3, comma, 2/3, and box that up. So that's how we solve using matrices. And that question is a lot easier than for B. For B, we will follow the same format, except that it looks a lot scarier, okay? So similarly, we are going to write it as an augmented matrix. So that means I'm gonna need a big one, but this one looks ginormous. 1, 1, 1, 1 equals 4, negative 1, 2, 1, no W, so 0 equals 0, 2, 3, 1, negative 1 equals 6, negative 2, 1, negative 2, 2 equals a negative 1. So that's the augmented matrix. Now let's try to get the diagonals to 0. Whoa, that one's already, I'm sorry, diagonals into 1. That one's already 1, so now I just have to work with the bottoms and turn them into 0. And now, because you should be, if you're used to it, we can do multiple steps at the same time. So this is step number 2. Step number 2, I will change row 2. I will change row 3, and I will change row 4. I will try to get all those values under the first entry to become 0. To do so, I'll start with row 4. Remember, I want to get the negative 2 in row 4 to become a 0. So we will multiply its opposite, which is 2. Multiply this right here, because that's the only one with the 1. So multiply row 1, and then add itself. Same thing with row 3. Row 3, we're trying to get 2 to become a 0, so its opposite would be negative 2 times row 1 plus itself. Same thing with row number 2. Multiply its opposite, which is 1. 1 times R1 plus R2. But remember, 1 times anything, it's itself. So this particular step, you can even think of it as just adding row 1 and row 2. So that's our next matrix. Okay, since I am not changing row 1, I'm going to copy row 1 over. All right, let's do row 2. Ready? I have to really be careful, and I'm going to check after each and every row once I'm done doing the basic math, so I don't make silly mistakes. Row 2 is adding this together, so that will give us 0. This will give us 3. This will give us 2. This will give us 1, and this will give us 4. Let me just really do a quick glance to make sure I'm good and I look good. All right, let me erase the circle so you're not confused on my next operation. Row 3, I'm going to take negative 2 times row 1. So row 1 is 1, so negative 2 times 1 plus row 3. So row negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 1 is negative 2 plus 3 is 1. Negative 2 times 1 is negative 2 plus 1 is negative 1. Negative 2 times 1 is negative 2 plus a negative 1 is negative 3. Negative 2 times 4 is negative 8. Negative 8 plus 6 is negative 2. Let me just double check to make sure my basic math looks okay. It does look okay. Next, again, I'm going to erase. I'm only doing this boxing and circling so you know what I am looking at, okay? Blue, okay. Next, I'm changing row 4. 2 times row 1, which is 2. 2 plus negative 2 is 0. 2 times 1 is going to be 2. 2 plus 1 is 3. 2 times 1 is 2. 2 plus negative 2 is 0. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. 8 plus negative 1 is going to be 7. So let me double check with that. 0, 3, 0, 4, 7. Good. So step number 2 is done. I have accomplished the ones and the zeros for my column number 1. Step number 3, I would like for the remaining, remember these all have to be ones. So what you want to do is look around in column 2 to see if you can switch any of the row 2, row 3, and row 4. And in this case, you can because these, okay, can be switched. And when I say switch, you have to switch the entire row. So switch row 3 and row 4. So we are going to write row 1 over 1, 1, 1, 1 equals 4, 0. Did I say row 3 and row 4? I'm sorry, row 3 and row 2. Okay, 0, 3, 0, 4, 7. So row 3 is now row 2. So 0, 1, -1, -3, -2. And row 3 is now row 2. So row 2 is now row 3. So 0, 3, 2, 1, 4. Let me just quickly glance at it to make sure I copy down everything correctly from the previous matrix, because if I don't, I have to go back, and as you can see, it's a lot of writing. Next step, number 4. Make sure these guys right here are now zeros. So to turn those into zeros, they're not too bad. So we are going to change row 3 and we are going to change row 4. And to change it to zeros, again, you take its opposite, you multiply the row above it that contains a 1, so in this case row 2, and then you add itself. Same thing with both, because they looks like they both have 3, so multiply the row above it that has a 1, which is row 2, and then add itself. All right, and let's do it. I'm not changing row 1 and row 2, so I'm just going to copy those guys over. Equals to 4, 0, 1, -1, -3, and -2. Okay, so here we go. If these guys were zeros before, they will most likely be zeros unless you made an error. Okay, so once you do the computation, this is going to be 0 here and 0 here. Okay, and then row 3, I'm going to have 0, 0, 5, 10, and 10 with my row 3 changes. Row 4, I will have 3, 13, and 13. Next, I would like to get this guy right here to become a 1. So that's my 5th matrix. So I'm changing row number 3. To get that into a 1, I will multiply all the row 3 by 1/5. So that means row 1 is not changing. Row 2 is not changing. Row 4 is not changing. Then all of these values are now 1/5 its original. Matrix number 6, I now would like to get this guy to become a 0. So I'm changing row 4. That means I want to take its opposite, multiply the row above it that has a 1, which is row 3, and add itself, which is row 4. That means I'm not changing row 1, so let's copy that over. I'm not changing row 2. And copying, it's a difficult task, because if you or I make any mistakes on these, then I got to go back and do it all over. So here we go, 0 times, this is 0. And once you do the computational, you're going to end up with, it used to be 3, 13, 13. You're going to end up with a 0, 7, and 7. So now we just have to get this guy to become a 1. So that's my matrix number 7. We are going to change row 4. To get that a 1, we multiply by 1/7 to the original entry of row 4. That means the first 3 rows did not get changed. 4, 0, 1, -1, -3, -2, 0, 0, 1, 2, and 2, 0, 0, 0, 0. I'm sorry, not 0, 1. 1/7 times 7 is 1, and then 1. Okay. So here's where we are at. Now, remember, we have x, y, z, and w. So the first equation you're going to have is w equals 1. Yay, you solved for it. Then next, you have no x, no y, and I'm going from bottom up. We have 1z plus 2w equals to 2. Well, if that's the case, if you know what w is, this will allow you to solve for z. Z plus 2 times 1 equals 2. That means z is going to be 0. Yay! You got 2 answers. Now the next equation is no x, but you have 1y minus a z minus 3w equals negative 2. Well, you know w, you know z, so now you can solve for y. Z is 0. Okay, well, w is 1. So when we add 3 to both sides, y would turn out to be 1. Whoop! Almost done. Now this last one, you have an x, a y, a z, and a w, and it equals to 4. Well, x is not known. We're trying to solve for that. Y is 1. Z is 0. W is also 1 equals to 4. If you solve for it, x comes out to be 2. So you have your answers, right? Oops, that's not big enough. You want to put x, comma, y, comma, z, comma, w. And we have all 4 values. X is 2, y is 1, z is 0, and w is 1. And that is one answer. It is consistent. Consistent means you have an answer.